In November 2020, a piece of silicon the size of a postage stamp broke the performance standards defining the laptop industry for a decade. Right before that moment, buying an Apple laptop meant accepting a difficult trade-off. You paid a premium price for a machine that would frequently choke on demanding tasks, throttle its own speeds, and run so hot the internal fans sounded like a jet engine. The performance gap had grown so wide that even lifelong loyal Mac users were beginning to voice the unthinkable. If you needed a reliable computer for heavy professional work, you were better off buying a Windows PC. Apple was on the verge of losing the professional creatives who formed the backbone of their user base. To keep them, they needed a solution that would do more than just refine their existing designs. It would have to replace them. This crisis traces its origins to 2005, when Steve Jobs stood on stage and announced that Apple would abandon PowerPC processors to partner with Intel. For years, the partnership held up to its promise. Apple laptops became faster, sleeker, and gained the ability to run Windows natively using Boot Camp. But by the late 2010s, Apple's design philosophy had shifted. Under Jony Ive, the company prioritized thinner and lighter chassis, often at the direct expense of the cooling systems required to keep high-end processors running at their full potential. This created a physical bottleneck. Intel chips required significant power and generated immense heat, yet they were trapped inside metal enclosures that were too thin to dissipate it. The machines were forced to dial back their own processing speeds to avoid hardware failure. The result was a lineup of high-end laptops actively fighting against their own internal hardware. What had been a strategic partnership with Intel had become a liability that Apple's design team could no longer engineer their way around. While users struggled with overheating keyboards and loud fans, engineers in Cupertino were already working on a completely different solution behind closed doors. The groundwork was laid in 2008 with the quiet acquisition of a small chip design company called PA Semi. That move allowed Apple to begin building its own custom silicon division from the ground up. For over a decade, Apple used the iPhone and iPad as a proving ground. They iterated on their A-series mobile processors, refining the ability to deliver high performance within the strict power and heat constraints of a handheld device. Through millions of mobile devices, they proved a critical thesis. Custom silicon tailored to a specific software ecosystem could outperform generic off-the-shelf processors meant to run on thousands of different hardware configurations. The strategic realization was clear. If Apple could scale this efficient mobile architecture up to a laptop, they could solve their thermal issues and their battery life problems in a single move. In 2020, Apple publicly declared its independence from Intel, announcing that they would now control their own processor destiny. To understand why this was a departure, look at traditional PC architecture. A standard computer is a team of separate parts: a CPU, a GPU, and memory modules, all physically separated on the motherboard. Moving information between these separate components takes time and energy. It creates data traffic jams and generates heat that limits how fast the machine can actually work. The M1 chip discarded this layout. Instead of separating these modules, Apple fused them into a single piece of silicon. By placing the processing cores, the graphics, and the memory all onto one unified chip, they eliminated the physical distances and communication delays that usually slow down high-performance computing. These architectural changes yielded concrete results: up to 3.5 times faster CPU processing and 6 times faster graphics, all while running cool enough to allow for a completely fanless design in the MacBook Air. The M1 did not just iterate on existing hardware, it replaced the traditional modular layout of a computer with a single, integrated system. Initially, many doubted that a company specializing in mobile phone chips could ever match the raw power of a desktop giant like Intel. That skepticism vanished when the benchmarks arrived. Tech reviewers and developers watched as the M1 shattered performance records while running demanding professional software effortlessly. The real-world impact was visible on timelines like this one. 4K video projects that used to take several minutes to render on high-end Intel Macs were suddenly finishing in seconds. Professionals were also seeing up to 20 hours of battery life on a single charge. For the first time, an entire day of intense creative work could be done without ever plugging into a wall outlet. When benchmarks showed a thin laptop outperforming high-end desktop workstations while using a fraction of the power, the industry's traditional reliance on separated, power-hungry components faced an immediate and urgent challenge. There was a time when devices like the PowerBook G4 represented the absolute edge of what was possible in a portable machine. As the hardware became hotter and slower in later years, that experience faded. But the M1 MacBook signaled a return to that original standard of seamless, responsive performance. By prioritizing efficiency over raw clock speeds, Apple demonstrated high-performance computing could exist without the heat and noise that defined their laptops for a decade. The M1 served as the catalyst for a shift in architecture that continues to reshape the industry today. The future of computing it pointed toward is one few were prepared for,